Here, maybe. Hi, everyone. My name is Celine, and I'm the moderator of the Innovation Room. If you have any questions that you want me to ask during the Q&A, just let me know. And I will start with a brief introduction to our first speaker. It is Javier Garcia, and he is the global lead of digital assets. So I will welcome you to the stage.
Thank you very much. Oops, quite high. So good to see that at least we have some people after lunch. That's a really good thing to see. So first of all, as an introduction, as I said, I'm leading digital assets at Kaleido. That's the company that I represent. Kaleido is an enterprise blockchain company that offers a wide range of services and products to our clients, going directly from chain infrastructure as well as Web3 middleware in a digital assets and tokenization stack. But today, what we're going to be showing is just a particular product that we open sourced in November last year. We did so in Singapore FinTech Festival, which is called Paladin. It's a product that resolves privacy in the EVM space, and we did the open sourcing through the previously called Hyperledger Foundation. Now it's called Linux Foundation Decentralized Trust. So what you're going to be seeing today is two examples that I'm probably going to be spending 7 or 8 minutes and giving some time for questions, where we have been using Paladin in real production use cases or with real clients, even with banks and financial institutions. The first one of it is the Guardian Wholesale Network. So a little bit of a background. The Guardian Wholesale Network is a multi-member and multi-asset and multi-currency network that was created under the Guardian framework in Singapore that is regulated under MAS, the Monetary Authority of Singapore. And it was created with one main purpose, right? Initially, there were three main pillars around use cases. One was around FX, foreign exchange, another one around asset and wealth management, and another one around fixed income. And all of these use cases were being done in separate networks, separate infrastructures, right? So last year, MAUS decided that it really made sense to have a common infrastructure for all of them. As you can see here, Guardian is a very big project there in Singapore that amounts for a lot of members, policymakers, regulators, and even financial institutions. And the main purpose that GWN, and those are the initials of the network, was to create a testnet that could deliver cross-use case composability, right? We really wanted to make sure that there was a shared infrastructure to start using all those assets across the different industry pillars, right? And as you're going to be seeing today, one of the main purposes from this network was, aside from showing composability, we wanted to make sure that we could have delivery versus payment, we could have payment versus payment transactions in a composable way. And every time we say composable way, sometimes we call it also the institutional DeFi way, because if you're more used to how DeFi works, where I can take an asset, I can just collateralize that asset, I can just lend something. We wanted to do a similar thing with traditional assets that banks are used to have in their balance sheets. So just a couple of the unique features of the Guardian Wholesale Network. As I said before, it was a multi-asset support. It's very cost efficient because it was just providing one single infrastructure for all of them. Given that composability that I was referring to before, it was open and interoperable for all the members. And each of them had their own specific configurations. And this is very important because that means that every member in the network had their own node. So having a node in the network, it's quite important for just making sure that you can send transactions and receive events, but it also has some drawbacks. And the main drawback is that you can see everything that is happening on the network, right? Blockchains, as default, they are transparent. So you can see what your competitors may be doing, right? So one of the key things we wanted to have here is how can we enable privacy? How can we make sure that if two financial institutions decide to trade a bond, that bond is only visible for them, and the other members of the network that have nodes cannot see what they're doing. They cannot see the amount they're paying for transactions, right? So this is the architecture that we had for the Guardian Wholesale Network. As you see, it was a network for 5 members. We had a combination of banks and asset managers. HSBC, Standard Chartered, Citi were involved, Schroders, UOB. So we had a big combination of financial institutions and asset managers, and as well as MAS as a regulator who was an observer in the network. And all of them had the same middleware stack and the same connection to that network. You will see there as well, there's some minor icon. Some of you may recognize that thing at the bottom, which is the B from Hyperledger Besu. So this was a private permission network that was created there just as a test net and to make sure that everyone had the ability to test freely what they wanted to test. And the main reason why we also did so is because us, as Kaleido, we are the enterprise maintainers of Hyperledger Besu. And we could just give them all the support in the network. So just giving you more and more details of what we tested. As I said before, all of the banks were using the same application at the top. That means they all had a common application that was equal for all of them. They all had the same front end, let's put it that way. And they had access to many different products, right? We had products around fixed income, and you see there bonds, repos, right? Things that really make sense. It's not just issuing a fixed income product. When I have a fixed income product, I can do more, right? I can collateralize that. I can do repos with them. We had the same thing for tokenized cash and FX. And on the asset and wealth management side, we had bonds. We had funds. And all those products had different roles. So you see there are a lot of roles, and indeed we had 15 roles in that network. Each of them were just participating according to what they wanted to be in each of the single transaction. That's where composability really makes sense, right? Sometimes you may become a custodian, on other times you may be an issuer, right? So they really wanted to test how that multi-party network and multi-workflow works. And then at the bottom, you see that we had that well-free middleware, and Paladin as the privacy ledger was incorporated in the network. Just to give you like very, very high level details of all the different sections that we had on the tokenized cash and the FX side, we tested a bunch of stuff. Obviously, the most interesting one is not the issuance of tokenized cash, because that has been tested many, many times, but it was more around how can we use different forms of cash for FX, right? How can we start having FX trades within that single network? If we move on into the funds side, we had a similar use case where we issued a tokenized money market fund, right? And we started to demonstrate how that life cycle of the product could be managed throughout all the roles that we had before, right? How could we distribute the money? How could we pay dividends on that money market fund? How could we have a secondary market on that money market fund? How could we redeem that money market fund? And finally, and just going more into the details of the privacy section, we did the privacy component really focus on the fixed income side. How could we have private zero coupon bonds? Private meaning they're just visible to the individuals in that particular transaction. And also that means that the money that was being paid for those bonds was also private, right? And after that, there was also a section around repos, repurchase agreements. How could we enable intraday per minute repo rate transactions in that single network? So just giving you a very high level explanation of how Paladin was implemented. As you see here, I could spend a lot of time explaining everything that you see on this slide, but at a very high level, what you see on the left-hand side is how, traditionally speaking, in the EVM world, bonds are structured. There's a bunch of small contracts that are created with an architecture that manages everything on the bond side: issuance, distribution, how you maintain the registry of the investors, everything, right? But there's a key issue there. And the issue is that everything is publicly available for everyone. So anyone that has access to the blockchain, that has a node, that can see the block explorer, they can see all transactions. They can see everything. So with Paladin, what we did here is just implement all the different privacy ledgers to make sure that we could have what we call need-to-know basis on that transaction, right? If I am an issuer or I am the custodian, I have access to specific data of that bond, right? I can know who the investors are. I can know their wallets are linked to a specific individual. I have that connection between a real person and a wallet address. That's a really important thing. But just for the issuer and the custodian, because anyone else in the network, they don't need to know that information, right? And on the other side, you see investors, right, with subscription data. If I am paying X amount of US dollars or Singapore dollars in this case to buy a bond, that's my private transaction. I don't want anyone else to see what I'm paying or what amount of the bond I have, right? So that was even private to the bond custodian or the investors. So just giving you some screenshots, and probably there's going to be a video later that explains this a little bit more. But it was very simple in the in that common application for everyone to just go create those bonds. They had templates already created that was simplifying all the process of deploying a smart contract. Everyone that we're working here in blockchain, we understand that just creating a product is not that simple. You need to create a smart contract, you need to deploy the smart contract, you need to wire everything. So we had really simple templates for them to understand whether they wanted to have a traditional bond that is publicly available for everyone or a private one. And also on the cash token, right? You see that C, meaning that it was a private tokenized deposit there as well, meaning it was only visible to the individuals that hold that token. From a visibility perspective, I was referring to having access to the node. I was referring to having access to the block explorer. So what you can see here is that with Paladin, I could also spend a lot of time explaining how Paladin works, but in reality, the tokens that we're using are using a UTXO model. They're just using states. So if you look into a public block explorer, the block explorer that was available in the network, what you see on the left-hand side, it was what everyone could see, right? It's just some inputs that were being spent and some outputs that were being created. Nothing else. There's hashes. No one understands what it is. But if you look with the lens of Paladin, if you are someone participating in that transaction, you get more details, right? You understand about the amount. You know who's the from address, you know who bought, you know who sell, right? Because you are part of that transaction and you really need to understand that information. So that's everything, very high level. I wanted to rush just to give some questions at the end. So that's what happened on the GWM project. And another one where we participated was on the UK RLN Hackathon, in which where we won the hackathon. It was also demonstrating how Paladin could be used to create a private permission network or public permissionless networks that use Paladin to protect some data and interconnect that network with the RLN UK infrastructure. So giving you very, very high level overview of how the RLN infrastructure is created is that what you see there on the left-hand side in gray is the infrastructure that has already been created in the UK RLN. There's an API on top that gives access to everyone, all the participating banks and all the participating commerces to get access to money, right? That's the UK Regulated Liability Network doing. They get access to either tokenized deposits. There's also access to central bank digital currency. There's also some testing around connecting this to open banking. But in this particular use case, we wanted to give access to the tokenized deposits, right? But everything that happens on UK RLN is linked to money. It's just cash because they want to maintain singleness of money on the cash leg. So what we did was what you see there on the right-hand side, right? On the right-hand side was we created another hyperlayer-based network just for the sake of the hackathon. It was really quick and we had to make this in one day. And in that network, what we did was we just created a tokenized bond. We used the same technology. We used Paladin, and what we demonstrated in this hackathon was how can I use privacy on the bond on an EVM chain, right? And connect that in a multi-network bridge to that RLN API. So in reality, what was happening here is that using the privacy that is already embedded in the RLN API, no one knows what's happening there because it's a ring-fence infrastructure. On the other side, we demonstrated that we could use Paladin with any EVM network to also apply privacy on the asset side. So in this case, it was a bond, could be applied to a fund, to any tokenized security. And here I have a quick video that I'll probably be jumping around. So I really want to give you an overview of what was the experience for everyone. I think it's here. It is here. Yep. Okay, so this is the common UI that all the participants had in this kind of like infrastructure. You see here that for this particular There you go. Yep. Yeah, so that's the access that you see where everyone have the ability to see the bonds. As you see, we're just going through the process of how to create a bond. It was a simple thing, as I said before. We had already created all those templates for everyone. You see that those bonds are confidential in a sense, but in reality, we already had created that for everyone. It was a really quick one to show how everyone could get access to it. In this particular use case, what we were just showing to the participants of the hackathon was this is the RLN API network, where we were just seeing all the different balances that were being involved. Because in reality, we needed to test interop, right? And testing interop is not saying, hey, I'm just clicking 3 transactions and everything is working, right? We really needed to test that. So we were showing the different transactions. And in this particular use case, we created a dashboard of how an investor, and we had different names there, could just participate in a bond secondary market, right? How in this use case, they could use that zero knowledge bond that you see, that set bond, and they could use many different payment assets. We could have used a confidential payment token in that hyperlayer based network. But in this case, we wanted to test that interop. So we chose an RLN payment asset. And after that, it was so simple as with every single transaction, you just what is the amount that you want to pay, that you want to buy from the bond, who's going to be your executor, and all the transaction should be going through. But one of the most interesting things about this transaction is that from the RLN perspective, and I'm going to be pausing here just because there's just some steps that are just particular to the transaction, and I'll just hop over to Paladin, is that if you're doing an integration between 2 different networks, you need to really use some sort of like escrow or HLTC contracts, right? So in this particular transaction, we really need to make sure that once the payment happens on the RLN, I can just release the securities on the EVM side with the bonds. But the most important thing, and I'm going to be just going very quick, and sorry to jump this, is to really demonstrate what was available on the what was available in Paladin and what everyone could see within the explorers. And so what you can see here, that is the Paladin Explorer that I was referring to. So as a participant on a transaction, I can get access to the private data that I have. I can go to those receipts and I can see all the amounts. You see that the amounts that are over there. You see the owner of the asset. You can see who you're selling to the asset. So that is something that you have access to because you participated in the transaction. Anyone that was trying to connect to the network and using the public explorer, they couldn't see anything. But it's even more important because if you have also Paladin, you're part of the transaction and you're trying to see what someone else did, you couldn't even see it. So it's not that because I have Paladin in the network, I can see everything. It's because I have Paladin and I'm part of that transaction, right? I have a need to know responsibility into this transaction, right? So you see, and I'll pause there again. You see, this is someone that was not part of the transaction, right? If they want to see what happened here, they just see some states. They just see some states that were confirmed, some states that were spent, right? It's completely private to the individuals in that transaction. I don't really want to just finalize this because at the end it's just showing the technicalities of how this worked. I think you really understood what was the benefit of using Paladin within the single transaction. If anyone is interested in looking at this at the full video, the UK finance team who organized the hackathon, they have everything public available. You can see the full video and the presentation over there. But I just have 2 minutes. I really wanted to give the floor to anyone who has some questions here. Yeah, go for it. This is a question.
Thank you for the presentation. Yeah, privacy is really important for the next-gen application in blockchain. So in a way that we can comply with the policymakers. But I have a question about how do you manage the user data? So for an investor, when he connects to your portal, how do you manage user data?
Yeah, that's a very important question because every time we talk about privacy, we end up just discussing whether we should be using one technology over the other at the smart contract level. We see a lot of conversations whether we should be using zero knowledge proofs, whether we should be using fully homomorphic encryption, but that's just the on-chain information. What we've seen is that traditionally speaking, in 95% or 90% of the use cases, when you really want privacy, you want privacy on the workflow. You want privacy with the off-chain data. So Paladin as a solution is a solution that covers the end-to-end, right? It's not just giving you a set of small contracts to protect privacy on-chain. It's also giving you a wallet to just understand how to, for example, create zero-knowledge proofs. It's giving you a transaction manager to send all that information to the chain, as well as an indexer to receive the information and really index the information that you really need to take care of. And talking about the user data, it is also coming with private databases that allow you to just store that private data for yourself, as well as, which is very important, and that's why I was referring to the workflows. There are a lot of workflows that happen between participants, and you need to send data to other participants through secure transport layers, right? MTLS, something like that, right? So all of that comes with Paladin and gives you off the shelf an infrastructure to manage the private data either on-chain as well as off-chain.
Thank you.
Good. I see that the time is already red, so I'm going to be closing this up. Just want to say that if anyone else is interested, we're happy here to discuss. As I said before, this is an open source project. Everyone can just go to the Linux Foundation Decentralized Trust, see the GitHub repo, and if they have any sort of questions, just feel free to ask. Thank you very much.
Okay. So